Good afternoon. So glad you have joined us today for DI Live's The Revival of Michigan Central Station in Detroit, making the old new again with 3D scanning. We invite you to stick around after today's presentation for a live Q&A. We will get started momentarily. We are just waiting a couple of minutes for others to join us. Okay, we'll go ahead and get started. Without further ado, I'll hand things over to Colin Williams.
Hi, welcome to our presentation today on CATI's collaboration with Ford Motor Company on their Detroit train station restoration project. My name's Cullen Williams. I'm an application engineer here at CATI, and today we're going to be taking a look at what kind of different technologies that we incorporated with Ford in order to help them along on their goals on this project. Let's take a look at a quick video from Ford, kind of showing the overview of this project and how it fits into the grand scheme of things from Ford's perspective. So as you can see, the train station is just a small part of the puzzle of the whole project that Ford is undertaking with relocating and revamping their entire campus. But specific to this project, the train station was purchased in 2018 with a projected completion date of 2022. Budget of $740 million was allocated to the restoration project. The general plan, as you saw from the video, is the first floor will be retail with restaurants that is open to the public, and then upper floors will be office space both for Ford and for Ford partners. So where does CATI fit into all of this? So a major focus of this project is the architectural restoration of the building itself, bringing it back to its former glory. Utilizing 3D scanning technology that we have here at CATI instead of manual methods lends itself to a much faster and more accurate process. The architecture is captured via 3D scanning, and those scans are then cleaned up and digitized in order to create tooling for the restoration pieces. So let's take a couple of examples here of pieces that we scanned and converted into CAD models for use in the restoration process. So we've got a ceiling tile scanned to CAD example here. So here we've got the photograph of the actual piece going to the mesh file generated by the scanner, and finally to the 3D CAD file that would be used in the tooling process. Next, we've got this ceiling cap scanned to CAD, and as you can see, the differences between the raw mesh data and then the cleaned up CAD file is a pretty significant difference, and it just really increases the ease of use when going to the tooling or the molding route. Finally, we've got some ironworks to take a look at here. So we're taking specifically a look at the more intricate details highlighted here, and again, converting that into a CAD-friendly format. So what tools did we use when we were on site with Ford? So we used three main scanners here. We've got the GoScan 3D, the HandyScan 3D, and the MetraScan 3D. And we're going to dive into each one of these in a little bit greater detail and why we brought these along for this project with Ford. But first, let's talk about how these scanners operate. They all three operate on the same basic principles of triangulation on reflective targeting. And what does that look like when we go to scan our parts? So let's say we're trying to scan up this transmission housing here. We need two pieces of information to create a usable scan. The first being the surface data itself, but we also need to know where that data is in 3D space. We need to have a reference frame. We place reflective targets on the part's surface, and the scanner will then capture those targets and create a reference frame based on that constellation of targets. Once we have that reference frame established, we can begin shining our light source, which is usually either lasers or white light, watching how that deforms on the surface, and then triangulating that back into usable surface data referenced off of that original origin. Let's take a look at the GoScan 3D. We can see that's actually real-time scanning speed right there. So as we talked, we needed some sort of a reference origin on the last slide. The GoScan can actually use several different options, not just the targets, to achieve that reference frame. So to review on the GoScan, we've got an accuracy of 2 thousandths of an inch with a measurement resolution of just under 4 thousandths of an inch. Recommended part size range of under half a foot to up to about 13 feet. Very high speed unit, 1.5 million measurement points per second. We saw in the video that live scanning speed. We're achieving that with 99 white light stripes. So this is a white light based scanner. So why did we bring the GoScan along for this project with Ford? The hybrid positioning that we saw from the video allows for very easy scan setup. So we don't always need to have targets or as many targets as we might need with some other scanning solutions. So anywhere that we wanted to get in and get out very quickly on an active job site, the GoScan was very key in those areas. So same thing, fast measurements for limited working time on the active job site and being portable as well. All we really need is to have a extension cord with a power source and we can be up and running very, very quickly with the GoScan. Now let's take a look at the HandyScan Black Elite. So as opposed to the white light of the GoScan that we just saw, the HandyScan uses a blue laser light as its light source. And this lends itself to much higher accuracy and higher resolution scanning capabilities than the GoScan. With an accuracy of 9/10,000ths of an inch and a measurement resolution of the same 9/10,000ths of an inch, we can get a little bit smaller on the part size as well due to that higher resolution of 0.15 feet up to 13 feet. 11 blue laser crosses allow for 1.3 million measurement points per second, so very, very fast scanning as well. It's also a metrology grade piece of equipment, something else that the GoScan does not have. So this, you can see the different certifications there. It is a fully calibrated unit. You can send it in once a year to Creaform for a hardware level recalibration, and this paperwork stays up to date. It's also a very versatile unit. You can see that we can scan a wide variety of surface finishes, including very shiny chrome-plated surface finishes with these very intense blue lasers that the scanner outputs. So why did we bring the HandyScan along for this project? Higher resolution scans for finer details that maybe the GoScan couldn't have picked up quite as well. The powerful blue lasers, like I said, lend itself to scan flexibility. So where there were different surface finishes that maybe we would have had issues with other scanners, the blue laser technology of the HandyScan really could tackle anything that we threw at it. High ease of use, again, same theme with the GoScan for an active job site. So we need to be able to set up quickly, we need to be able to get in and get out and not have that rigid and hard of a setup and be able to do it all very, very quickly. Now we're taking a look at the Metroscan 3D system. So as you can see, the Metroscan is another blue laser system very similar to the HandyScan, and we're also getting very similar accuracies and resolutions as the HandyScan. The main difference between the two is that the Metroscan is very useful for larger volume scans, holding that accuracy of the system over a larger volume. Whereas it may take a little bit more of setup time. As you can see, it's a two-part system here with a tripod camera system as well as the hand scanner itself. So HandyScan is a little bit faster setup, a little bit lower accuracy on larger volumes, where the opposite is true with the Metroscan system. 15 blue laser crosses allow for 1.8 million measurement points per second, so the quickest of all three of the scanning systems. The Metroscan system is also metrology certified. You can see the certifications off to the right with a measurement resolution of 9/10,000ths of an inch with new surface reconstruction. Limitless scanning volume, a portable setup, again, something very critical for being on an active job site. So why did we use it for the Ford project? Like we said, great volumetric accuracies for larger scans. Some of the large archways that we needed to scan were things that needed to be done all in the same scan over a very large volume, and that's where the Metroscan really helped out. Again, the blue lasers were really key on scanning multiple different surface finishes all within the same scan and allow for higher resolution for fine details needed in those scans. So when the art meets the science, let's take a look at what we actually did on site at Michigan Central Station.
About 20, 25 years ago, I was living in downtown Detroit when I was in my mid-20s. And I just remember being, a history buff and looking out that window and seeing that 18-story building and just being amazed at what that building could be. And just, for a guy that's into history, just always thought hey, what went through that building? What did it look like in its heyday? So one of the great things about this project is it not only brings back jobs, it brings back people, and it brings back a community. The story of this building is the story of Detroit.
Joe Ford, great-grandson of Henry Ford and executive of Ford Motor Company. He would frequently drive by the building. You keep looking at it and think, this is the symbol of Detroit. This is what we're known for, so he's wondering what can he do, how can he make a difference? And decided, I'm going to take over this building and we're going to make this a hub for our mobility platform.
I've always been interested in how the inner workings of things are. Like even as a kid, I was always taking apart computers, taking apart broken appliances and things like that. And that kind of really relates to the job here at CATI and the job here at Ford, in that we have technology that helps us kind of break down the physical parts and structures and architecture that we're looking at and turn that into usable 3D data. So here for Ford, we're taking these very intricate designs and being able to digitize those for the purpose of reproduction.
Back in the 60s, my aunt lived in Florida, so she would come up here to visit us by train. I'd come down here with my mom and we'd wait for her and pick her up to take her back to our house. Yeah, it's a real honor to be part of this project. Coming back and seeing how bad it really got, but it's, as we dig into it, the bones are still there. It's still good bones, and we just got to get everything back into shape and bring it back to its life, bring it back to its luster from the 1913s. So we reached out to CATI to see how they could maybe help us out, restore some of the ceilings and window components. As a partner, we're really appreciative of them coming in to help us out with this project. That's going to be such a great honor to restore and bring back to life.
With the Creaform 3D scanners, what we're able to do is digitize what we see right in front of us today with all of its flaws and everything, take that into software where we can digitally repair it, which makes the process a lot more precise and a lot faster, and we can then use those digitized files during the restoration process to recreate those physical pieces in their original form. We want to be able to take multiple pieces that are identical with different areas of damage on them, and we can take scans of part 1, 2, 3 and combine them together, and through all of the data from all three of those, we'll have 100% good data. If we can't find an area undamaged on every single piece, or maybe we only have one original piece, that's kind of where the art meets the science, and that's where we have to kind of start playing with the file a little bit more artistically, kind of play with it almost like digital clay to get that restoration done in the most accurate way that we can.
So having CATI on board, it allowed us to capture that existing condition information and then fabricate those elements that are missing. They've been a great partner to work with. They come to us with a great tool that's very efficient and quick to allow us to collect that information. And without them, I think we would have been using traditional methods, much more inefficient, much less accurate. So having them on board has been great. Through CATI's work, we're able to take that existing condition information and we're able to replicate those missing decorative elements on the windows and basically restore the original architect's intent.
At CATI, our customers get really fast, accurate turnaround times in terms of quality control. And for reverse engineering, it not only speeds up their process, but it allows them to measure different features on more complex parts that aren't possible with any other methods. Creaform scanners are very innovative technology, and we're using this to restore this area that used to really be an innovation center in the past and a great hub of technology. And now this next generation of technology has come along. We're going to help that come back to life.
CATI is a technology solution provider working with Ford Motor Company on a very unique project. We help customers solve problems, and this is a big problem we're helping Ford Motor Company solve. We're really using technology to leverage the past to know where we're going for the future.
So I want to thank you for joining us today, and hopefully you enjoyed seeing the behind the scenes of how we got the job done with the architectural restoration with the Ford project. Thanks again.